Hey everybody, so the plan right here, we're going to simplify some radicals. So the radical is just, I call it, at this point in time, we're going to take square roots. And what that means is the square root of 4 means 2 times 2. You can pull something, two things that multiply by themselves. So 2 times 2, 8 square root of 81 is 9 times 9, 256. That's a bigger one. I think that's 16 times 16. 121 is 11 times 11. So there's a pair of numbers that pull out of a square root. So there's all sorts of interesting things that happen there. Like this one, if we have 64 over 81, I know that the square root of 64 is 8. Square root of 81 is 9, so I just get 8 over 9. So that's kind of where we're starting. But what I want to do is go down and pull some that are not perfect squares. So I went ahead and wrote down the first 10 perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And you should have a clock that has all of the square roots up to 12, and plus maybe 13 times 13 is 169, some other good stuff. Those are all the perfect squares going from 1 to 100. And then I'm going to look at this, like right here it says 24. So what I want to do is figure out, is there one of these perfect squares up here that goes into 24? So I'm just going to go over the way we've done it this year. I'm going to make a little t-chart and say, right, what are my vectors of 24? I know that 120 times 24, but that's not, there's no perfect square root there. Then I'm going to go 2 times 12. Is 12 a perfect square root? No. 3 times 8. Is 8 a perfect square root? No. 4 times 6. Is that a perfect square root? Yes. One of those is perfect. So I'm going to stop right here and say that's the one I want. And so then I'm just going to keep going and take the square root of both things. Over here it says I can pull, if I have two things multiplied by each other, I could take the square root of each of them individually. So then I look and I say, okay, what is the square root of 4? Well, the square root of 4 is 2. So I get to pull that square root out. It's kind of like a kid at recess. If they have a pair of boots, they can go out in winter. Well, 2 times 2, that's a pair of 2s, so they get to go out. But the square root of 6, there is no pair for the 6. Doesn't break down into anything nicer. So there we go, 2 square root 6. How about 48? Well, 1 and 48, but that doesn't help us. 2 and 24. Ooh, well, maybe you know something right away. 3 and, so I'm just counting up. 3 and 16. 4 and 12. Okay, I now have two options that would work. Which one has the bigger square root? Yeah, this one right here is better. So square root of 3, square root of 16. Can I take the square root of 3? I can't. So my solution is 3, but I can take the square root of 16, so I write that on the outside. A pair of 4s comes out, so 4 square root 3. Now, oftentimes what I see a whole bunch of you do is you pick this one, which is great. That's not really a problem. I can take the square root of 4, the square root of 12, and so I get 2 square root 12. But what you need to see is that 12 could break down even further. So 12 could break into 4 and 3. So I could pull out another square root of 4, which would make 2. If I do that, then I have my original 2 times 2 square root, the 3 is left. If I multiply these two together, they give me the 4. So, does it give me the same answer? Yes, it's just a longer process that sometimes people miss. So let's look at this one, square root of 72. Why don't you try both the square root of 72 and the square root of 90, pause them, try them, and then come back. All right, square root of 72. This says suppose I use 9 times 8. Well, there is a faster way, but let's just suppose that I do that. Well, what's the square root of 9? 3. What's the square root of 8? I don't know yet, so I'm going to write it down. I know it's not perfect. However, there is another perfect square that goes into 8. What is it? Yeah, 8 is 4 and 2. So I take the square root of 4, take the square root of 2, and the square root of 4 is 2, but the square root of 2, I can't take that yet. Right, but what am I missing? Yeah, I'm missing this 3 that I have to multiply in. So 3 times 2 times the square root of 2, that gives me a final solution of 6 square root 2, which means 72. I really could have broken that into 36 times 2 right away. But either way, it doesn't matter if you go fast or slow, just that you get there in the end. Now look at 90. What perfect square goes into 90? Yeah, I'm going to do 9 times 10. So I break down the square root of 9, square root of 10. I can take the square root of 9 as 3. Square root of 10, can't take that down. There we go. So hopefully that's a quick refresher. And if you need another way, there's a second video that gives you a completely different way and a different process to do this.